Hi, let's talk about efficiency. According to the dictionary, the word efficient means using resources such as time, material, or energy well without wasting any. So that's why the definition of efficiency in physics will be described using this equation. Any one of these will be fine. Let's look at the first one. You can say useful work done divide total energy input or output. Then you may ask, when do we use the total energy input or when do we use the total energy output in this case? And the answer is it doesn't really matter because they are always the same. If you don't understand why, try to recall the law of conservation of energy first. Can you now recall the statements that we have learned? The statement is that energy cannot be created or destroyed, but it can change from one form to another. So that is why no matter what happened, how much you have input in total in a system will eventually be the total energy that you output in different forms add together. If you still don't understand, that's totally fine. Once you see the example, then you understand it very quickly. So now let's quickly look at the other two version of the equation first. So now we said useful work done over total energy input or output times 100% because usually we represent that in percentage. Instead of saying work done, we can also say energy output, all right, instead of work done. So both of them are useful. I mean, if you look at all three, both of them are referring to the useful one anyway. So it's very important that you know for a certain system what energy are being useful. It will really depends on the purpose of the system. So you cannot generalize them or memorize a certain kind of energy because it really depends on the aim of the system. Anyway, so here instead of using work done, you can say energy output, and whatever below the fraction is basically the same. The one that is slightly different is the last one, which instead of using energy, we can actually refer it to the power output. However, if you use power output as the top of the fraction, then below the bottom part of the fraction, you should do it in a parallel manner. That means you also should use the total power. Again, no matter input or output. Okay, otherwise it would not be fair. And that's pretty much is the formula for efficiency. And please make sure you remember one of these formats because in the exam, in case you did the calculation wrong, even if you state this equation, you probably will get 1 mark also. So it's always good to put down an equation before you try to do the calculation. Okay, if you're okay with that, then try to do this example by yourself using the equation. Pause the video and do it yourself first.
A few moments later.
Let me show you how I would do it. So first of all, you should write the equation, of course, as usual. So you probably writing efficiency, and if you want to be a bit more lazy, then you can use a symbol, and you cannot find the symbol on the textbook. So if you try to search on Google or anywhere, you'll find out the symbol is something look like this. This is a Greek letter called eta or eta, right? Depending on British or American English. And yeah, that will be the symbol. And then you can write the formula again. So assuming I'll be using the first formula, allow me to be lazy, I'll just say this is the formula. And you can write again if you want to. And normally in the exam, of course, you should write it. And so here, what I would usually do is draw a long fraction line. And then you can see that this is the total power. Actually, we are doing power, so we should actually do this equation instead, right? Not the work done, using useful power output over total power input. And so we have 200 watts will be the total power, I believe. So 200 will be written here. And then we will have light, sound, and thermal energy to be these three values respectively. Then you have to think about which one is the one that is useful. think about that for television. Of course, you would need the light because you are watching the television unless you are blind. So I assume you don't. So that means it is useful. So let's put down 100 here. And sound would also be useful again unless you are deaf. Sorry, no offense, but that's applied to most of us. That would be 40 watts. And then for thermal energy, it will be referred to 60 watts. But then for a television, I believe no one will use television for its warmth. I guess like you don't switch on the television and say, hey, I want to warm up my room, and that's why I turn it on. Probably not. So we would disregard that in this sense, right? When we're talking about television. So at the end, we'll be calculating this and try to find out the answer, and that would be 160. Yeah, so that would be 80%. All right, so 80% is the efficiency of this television. Since we talk about efficiency, there's no way that we don't talk about perpetual motion machine. Perpetual machine is believed to be some sort of a machine that can run forever. That means they literally have 100% efficiency. However, it's actually physically impossible because whenever you build a system, there's always very tiny parts of the energy always continuing transforming into some form that is being wasted, especially work done against friction, because it's very hard to build a system without friction. And for some other system, it may not be able to retain all the energy as well. So I put 2 videos on the playlist, and please go and watch them later on. And I promise it's actually very interesting. So if you want to put down the description for perpetual motion machine, then you can follow my wording here. As a matter of fact, perpetual machine was actually a toy at the very beginning of the time, because only probably the royal group of people who have enough money, who are rich enough to build these kind of machine for fun. So it's actually kind of a toy for them instead of doing actual science purposes. But anyway, if you could somehow build a perpetual motion machine by yourself, and if it is really true that the efficiency is 100%, congratulations, you get a physics Nobel Prize.